Happy Monday, everyone. Thanks for joining us for another live stream Star Tour. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. And if you're joining us for the first time, welcome. Glad you're tuning in. And if you've checked out one of our live streams before, thanks for coming back. Thank you. I wanted to give a special thank you to our Union Station members who continue to support Union Station even while we're closed to the public, and your support lets us do these really cool kind of different types of things for us to bring all of our programs to you, like our live streams and the Instructables that my colleagues in the Science Center are posting on the Facebook pages. So thank you so much for your continued support, members. We really appreciate you all. So just to recap what the plan is for these streams moving forwards, on Mondays today and Mondays moving forward, we are going to spend our stream doing a Star Tour, and that'll be sort of a what's up for the week, where I'll go over different things you'll see. We're going to go stargazing this week. That'll be on Mondays. Wednesdays will be the day where we focus on specific topics. So last Wednesday we gave a solar system tour. This Wednesday, the theme will be stellar evolution, so the life and times of stars. We'll talk about how stars are born, how different types of stars live, and then we'll focus on how stars die, with the special interest looking at black holes. So if you're curious about black holes and all the science behind those, as well as other things about stars, tune in on Wednesday. We'll take a deep dive there. And then on both Mondays and Wednesdays, you're welcome to chime in the comment sections of the videos, and we'll be answering those as we go along. There will be limited time on Mondays and Wednesdays because we're going to be working through our regular program content, but Fridays are Fan Friday, and that's the day where we'll focus completely on all the questions you ask, and any questions we miss on Mondays and Wednesdays we'll bring up on Friday. And so Friday will be all about talking to you guys and answering questions as they come up. So that's kind of the structure we're looking at. I'll talk about next week's plan a little bit later this week to give you kind of a tease for what we're looking at for programs then. Again, just wanted to get you all on board for this week. So today we will be doing a What's Up Star Tour. We're going to look at what we can see in our evening skies this week. There's a lot of good stuff, and if you've tuned into the Star Tours already, we're going to be reviewing some things that we looked at last time, and hopefully we'll be looking at some new things that you missed out on those other Star Tours. The night sky is always changing, but there are some things that do stick around and are always worth mentioning. So we're going to head back over to our view of the sky. This is a program called Stellarium. That's what we're using. Stellarium is a free piece of software you guys can download to your computers at home. I believe it's available for both Windows and Mac. And this is going to be a virtual planetarium for us. So we're going to be able to look at things that we can see in our Kansas City skies. And in the daytime, we can already see our Kansas City skyline, looking out over the lawn of the Liberty Memorial at the World War I Museum. We can see that standing behind us towards the south. The sun is low in the western sky. These streams will be at 6 p.m. every day for now, so hopefully you guys can keep track of that schedule. So the sun is pretty low in the sky as it is setting. As time goes on, as we get closer to summertime, the sun will be higher in the sky and it won't be setting quite as early. But since it is springtime, the sun is still setting relatively early, but the days are getting longer. And continuing around here, we see all of our Kansas City skyline. Now, our first star is up, our daytime star, the sun, but the sun is so bright that it's impossible to see any other stars in the daytime. Of course, the stars are still up. They're just hiding behind that blue sky. We can actually turn the constellations on in the daytime if we can see them right there. But of course, the human eye can't see them. There are some things, some astronomical objects you can see in the daytime. Occasionally, you'll be able to see the moon in the daytime, depending on what phase the moon is in. The moon is in its gibbous phase or full, then it's very bright and often visible in the daytime, either in the early evening or early morning. But the moon is not visible right now. We'll talk about the moon a little bit later. But for now, we are wanting to bring out our evening skies. We're going to go ahead and fast forward time to sunset. And as the sun sets, We'll be able to see the stars out. There they are. We're going to pause right around 9:30. You do have to wait about an hour after sunset for twilight to kind of get out of the way, so you can really see those stars clearly. And now at about 9:30 p.m. Central Time, you can see the stars. Now this is a simulated view of our night sky. Obviously, it's on a computer screen or your smartphone. But this is especially simulated because this is not the view of the night sky you would see in downtown Kansas City. When you're near a big city like Kansas City, there are a lot of factors that make it really difficult to see the stars. And those factors come from man-made light sources like buildings and streetlights and car headlights. We call all of these things combined light pollution. Man-made light sources aren't the only things that cause light pollution. The moon is very bright sometimes, and it will also cause light pollution as well. So that could be considered light pollution, but pollution has a connotation of man-made. So we are usually talking about those man-made light sources when we talk about pollution. So in Kansas City, you'll see far fewer stars, at least when you're downtown, near civilization. If you want to go stargazing, you would have to travel about an hour away from Kansas City. Here in the Midwest, if you drive about an hour away from town, you can see the stars pretty clearly. And that's so we're lucky to have these views of the night sky here in the Midwest. I do want to point out, if you're curious about where the best place to go stargazing is, there are some really great sources. You can do a quick search in your favorite search engine to find maps. Just look for light pollution map, and you'll be able to find some great websites. And I can just go ahead and show you one of these. Let me pull it up here. This is darksitefinder.com. I'm not endorsing them. There are a lot of different sources you can choose from. There are also smartphone apps you can download that have the same functionality. These are basically maps of light pollution. So we can see here basically how much light pollution you'll experience depending on where you are. You can see a lot of the eastern United States has a lot of light pollution, and luckily Kansas City is sort of right on the edge of the western United States, which has far fewer light pollution. So Kansas City is right here. So if we zoom in, you'll be able to see in the background, map's not quite updating, but oh, there we go. So you'll be able to see that quite a bit of metropolitan Kansas City and the surrounding areas have quite a bit of light pollution. But driving out west, past Topeka or down near Emporia, there are a lot of great spots for some really great stargazing. So you don't have to go too far. And even if you get into these sort of yellow or green areas, you'll still get a much better experience than anywhere near Kansas City or Overland Park or Shawnee, places around there. So keep that in mind if you're planning on stargazing, so you can find a good spot. And again, just do a quick search on your favorite search engine for light pollution map, and you'll be able to find great sources for that. But we are going to keep a simulated view of our night sky for our tour today. So this is what you'll find if you get away from those bright city lights. These are the stars we can see towards the north. Now, I like to start in the north because there are a few patterns here that a lot of people already know. So I like starting with those since they're familiar to you and they kind of familiarize you with, helps you get your bearings in the night sky. These two shapes look like big spoons in the sky. Here's a little one here, and then up here is a big one. These are called the Little and the Big Dipper. Now, the Big and Little Dipper are very famous patterns, but they're actually not official constellations. There are 88 official constellations in total. These were picked back in 1930 by an organization called the International Astronomical Union. That's the same group of people who recently demoted Pluto, so we can thank them for that one as well. Out of these 88 patterns, 42 of them are animals, 29 are inanimate objects, and the other 17 are humans or characters from mythology. But there are a lot of stars in the sky. On a clear night, you can see about 2,000 alone with the naked eye. So it stands to reason that people around the world see more than just 88 shapes in the sky, right? They see the stars in all sorts of different ways. So any pattern that's famous or well-known, but is not an official constellation, we call an asterism. So an asterism is an unofficial pattern. And there are a few asterisms I'll point out during our tour. Now, these stars are shared with two official constellations. The constellations are named Ursa Major and Ursa Minor, which means the Big Bear and the Little Bear. The Big Bear contains the stars of the Big Dipper. The tail of the bear is the handle of the spoon here. The body of the bear contains the spoon plus these two stars. The head of the bear goes over to this star. And then its legs extend up into the sky. It's kind of upside down in the spring and summertime. Again, there's the tail, the body, the head, and the legs. Let's take a look at that. So there's the big bear. The stars of the little bear are a bit dimmer, but you can kind of imagine sort of a similar pattern. I think this program doesn't have the lines there, but again, you can kind of imagine a tail and a body as well. Now, there are many different stories about these bears from different cultures throughout history. A question I often get asked is, why do they have such long tails? And that's a pretty good question, and it's a question we don't really have an answer to. There are conflicting reports and conflicting theories. Some people think, some scientists think that these were meant to be raccoons in certain Native American cultures, but there was a translation error when raccoon was mistranslated as bear. But there is recorded evidence of other cultures around the world seeing these as bear patterns dating back thousands of years, so who's really to say? Just one of those things that's kind of lost to history. Now, there is a very famous star at the end of the little bear's tail, and this star's official scientific name is Polaris. It has another much more famous nickname. We call it the North Star. Now, the North Star is pretty special. Some people think that it's the brightest star in the sky, but that should be clear that that is not the case. In fact, Polaris is the 45th brightest star, so it's not even anywhere close. You don't get any prizes for winning 45th place. Polaris is special for a different reason. It's called the North Star because it always points north, and this goes for no matter where you are on Earth. I know a lot of our people are a lot of our audience are tuning in from places around the country as well as around the world. And no matter where you are on Earth, if you can find that North Star, you can always find north because it always points north. And even if I fast forward time throughout the night, you see stars actually spin around our night sky. And no matter what, the North Star will always stay in roughly the same place, always pointing north. Let's get back to around 9:30. Now, why is that the case? Well, I actually brought a visual aid today to help us understand that. So let me bring back this view here, and let me try to orient myself. We're trying out something new here, folks. All right, so this is what's called an armillary sphere. And this is kind of like a planisphere, which is a flat star map you can make yourself at home. In fact, if you look on the Union Station Facebook page, there is a link where you can download a planisphere template and cut it out and tape it together yourself if you'd like to make that at home. This is sort of a 3D star map. What we have here is the Earth in the center, which is sort of transparent thanks to my green screen here. Oh, that's just because the water is blue. In fact, let me try to adjust that. I'm gonna let you see behind the curtain a little bit here. So we are gonna just turn off our green screen here, blue screen as it were, so we can see this armillary sphere. So there's a globe in the center, as you can see, and then we have a tiny little model of the sun right there, and this is just for the relative position of the sun. As we know, the Earth is tilted on its axis about 23 degrees, and we can see that tilt here, where the sun is angled in this way, our relationship to the sun. And then we can see around the globe, we see all the stars laid out. Now, we call this our celestial sphere. In reality, stars are not a flat sphere, obviously. Some stars are much farther away than others. But this gives us sort of a point of reference to understand where the stars appear relative to the Earth. So, as we know, the Earth rotates around its axis, sort of spinning around like a top, and that point of rotation is the North Pole, right? The North Pole is where the Earth spins around. And if we shine the light straight up into the sky at the North Pole, we would find Polaris. So you should be able to see part of the Little Dipper right there. So there's the spoon of the Little Dipper, and then Polaris would be right under this bolt here, the North Star. So as the Earth spins around, the other stars will move their positions relative to the Earth, but the North Star will always stay in relatively the same position. Hopefully that gives you a little bit more of a three-dimensional idea of how that all works. Let me make this background disappear using the magic of computers. All right, there we go. Okay, so let's get back to our night sky. So that's why the North Star will always appear to stay in the same place. Some people often ask if there's a South Star. There is not a bright star in the Southern Hemisphere, sort of directly below the South Pole. And explorers in the Southern Hemisphere, before GPS and compasses, they used a different set of stars called the... they used a constellation called the Southern Cross, as well as some other stars next to it called pointer stars. And we can check that out during a later tour if anybody was interested in that. But we're going to focus on our Northern Hemisphere night sky for now. Let's continue on towards the west. There is a pair of constellations, actually kind of in the northwest, that are fairly famous and easy to spot and easy to learn. The first one looks like a little W, a little zigzag. This constellation's name is Cassiopeia. Next to Cassiopeia is a little house-shaped constellation. This one's called Cepheus. Now, let me try to... There we go. Now, these patterns seem pretty simple, but ancient people, I'm pretty sure, had much better imaginations than we do today, because they saw these patterns as these complicated shapes. Not really sure where they got that from, but there you go. So Cepheus and Cassiopeia were the king and queen of an ancient African nation. The queen Cassiopeia was very beautiful, but she was also very vain. She liked to brag about her beauty. One day, Cassiopeia boasted that she was more beautiful than the daughters of Poseidon, the god of the sea. When Poseidon heard about this, he was not very happy, as you can imagine. A mere mortal claiming she was more beautiful than his immortal daughters, he could not let that stand. So as punishment, he cursed their land with years and years of flooding, washing away many of their crops and sending their kingdom into a terrible famine. 1 second. Cepheus and Cassiopeia tried to appease the god Poseidon and ease his wrath. They gave him many gifts and offerings, but nothing seemed to work. In the end, they eventually did what any two good parents would have done in the situation, and they decided to sacrifice their own daughter Andromeda to the sea god. Andromeda is a constellation that is prominent in our winter skies. Unfortunately, it has since set, so we won't be seeing the rest of that constellation in our spring skies. So I guess we'll just have to come back to the planetarium when we're back open in the fall to catch Andromeda rising in the east and to find out the rest of that story. Was that for a shameless plug? For now, we are going to go ahead and hide those constellations, and we're going to continue on towards the west. Now, I'm actually going to rewind just a little bit back to around 9 o'clock. This will still be twilight, but we'll be able to see a few constellations, some of the brighter ones that I'd like to point out. Some winter constellations that are setting out of sight. First up is Taurus the Bull. You can find it by looking for this bright V pattern. This is the bull's head. His horns go up into the sky to these bright stars, and then here's the bull's body and front legs. Taurus the Bull represents a couple different characters from a few different mythological traditions. To the ancient Mesopotamians, this bull was a monster that their hero Gilgamesh fought and defeated. To the Greeks, this bull represented Zeus, the king of their gods. Zeus had this bad habit of disguising himself as animals and coming down to Earth to mess around with mortals, and he used this disguise to kidnap a young princess named Europa. He kidnapped the princess by swimming across the ocean after tying her onto his back, and this is why people say we only see half of the bull constellation, because his other half is submerged in water. On Taurus's back is a pretty cool deep space object called the Pleiades star cluster, or Seven Sisters. Most people can see 6 to 7 stars here with the naked eye. Some people think it looks kind of like a little miniature dipper. In reality, though, this star cluster contains about 2,000 stars that are all bound together by gravity. These stars are also siblings. They are all born together from the same nebula. We can see the leftovers of that nebula reflecting the light from these young stars. And right between Taurus's head and the Pleiades cluster is this bright point of light right here. Now, you'll see this bright point of light during sunset. In fact, it's so bright you'll even see it before the sun finishes setting. And at first you might think that this is just another bright star, but there's something different about it. If you compare it to stars nearby, you can see that difference. As you can see here in our simulated planetarium, the stars are twinkling. But this object is not twinkling. Now the reason stars twinkle is because they're very far away from Earth, and it takes a long time for a distant star's light to reach our planet. By the time a star's light does reach the Earth, only a tiny amount of it is able to pass through the Earth's dense atmosphere, and our atmosphere causes that little bit of light to become distorted, making it appear to wobble and twinkle. But this object right here is much closer than distant stars, so a lot more of its light is reflected back towards Earth, and it appears as a wider disk of light, so it does not twinkle. This is a planet. You can also tell it's a planet because it won't be in the same place every night. Planets appear to wander around our night sky as they orbit the sun at their own pace. This is how they got their name. The word planet means wanderer in ancient Greek. And this wanderer you'll see in our western sky tonight is Venus. Venus, go away, Taurus. Venus will be the brightest point of light in the night sky tonight. It's often nicknamed the evening star or the morning star. It's not a star, of course, but it will always appear either in the early morning or early evening because Venus is closer to the sun than the Earth is, so it will always appear to look like it's close to the sun. Another interesting fact about Venus is because it is closer to the sun than we are, it appears in phases. In fact, if we zoom in on Venus, we can see that it actually is in a crescent phase right now. And even though only or less than half of Venus is visible, it is so bright and so close to us that it does outshine all the other stars. But because Venus does have phases, you can actually see those phases if you look at it through a telescope or even a basic pair of binoculars. Let's zoom back out here. We're going to continue on to one of my favorite constellations, and it's actually the brightest constellation in the night sky. It's called Orion. Orion the Hunter, one of the most recognizable patterns in the night sky. Many are familiar with Orion's famous belt here, outlined by these 4 stars. These are meant to be Orion's feet, and here are his shoulders. This cluster of stars is Orion's head. In one hand, he's holding a bow or a shield, in the other, raising a club or a sword. Orion was a famous hunter from Greek mythology. Like Cassiopeia, though, Orion enjoyed bragging about himself. One day, Orion boasted that he was such a good hunter, he could capture every animal on Earth if he wanted to. When Artemis, the goddess of the hunt, heard this boast, this made her very upset. After all, it was her job to protect the animals on Earth. So as punishment, she sent a giant scorpion monster down from Mount Olympus to battle Orion and teach him a lesson. The hunter and the scorpion fought for days and days on end, and they were so evenly matched that they both struck fatal blows on one another. And as they were both about to perish, Zeus, the king of the gods, stepped in. It turns out Zeus had been watching this spectacle, and he was so entertained by their fight that he captured both of them and threw them up into the stars, so that they would continue to fight and chase each other for all eternity. Scorpius is a summer constellation, so we'll see him rising later in the year. And these 2 constellations never quite catch up to one another since they are on opposite seasons. One of my favorite deep space objects is hiding below Orion's belt. Some people call this smaller line of 3 stars Orion's dagger or his sword hilt. This is actually a gigantic nebula that's visible to the naked eye just barely, and it's easily visible through a pair of binoculars or a telescope. It's called the Orion Nebula. Now this is a little tease for what we'll talk about on Wednesday, because the Orion Nebula is a stellar nursery. This giant cloud of gas and dust is giving birth to new stars. So if you tune in on Wednesday at 6 p.m., we will be talking all about how stars are born and how they spend their lives, and we'll be talking more about the Orion Nebula. But for now, I just wanted to point it out and show you that it is right there in our night sky. And it's pretty big, actually, and still a little faint, so you'll need a telescope or binoculars to see it more clearly, but it is right there. The brightest star in our night sky is hiding just below or just above the edge of the World War I memorial. This is the star Sirius. Sirius is nicknamed the Dog Star. It's part of a dog constellation. You can see kind of peeking out there. But I did just want to point that out. That is the brightest star you'll see. And remember, you can tell it's a star because it's twinkling. You can also identify Sirius specifically by drawing an imaginary line through Orion's belt. It points kind of right at the star. Let's continue on. a little bit higher in our southwest skies, you'll find a constellation named Gemini, the twins. This is kind of a fun and easy constellation to spot. It looks like two stick figures holding hands. These two stars are the stick figures' heads. Here's one head, his body, arms, and legs. Here's the other head, his body, arms, and legs. These twins were named Castor and Pollux, and they were a famous pair of Greek heroes. We've got Leo the Lion in our southern sky above our memorial here. You can find Leo by looking for another asterism. This one looks like a backwards question mark or a coat hanger hook. This is Leo's head and his mane. Here's Leo's body, his front paws, and his tail. Sort of looks like he's lying down. Anybody? Lying down? No? Me? Alright, that wasn't that great. Leo represents the Nemean lion. This was the ferocious beast that Hercules fought and defeated during the first of his 12 labors. Then rising over in the east, we have Virgo the Maiden. She looks like kind of a big stick figure. This is Virgo's head, and here are her arms, and then her legs are just they're just starting to rise over in the east. Virgo represents a goddess of fertility or harvest. She's often depicted as carrying an ear of grain in one hand. In fact, let's fast forward a little bit so we can see it. Here we can see the picture. She's holding an ear of grain to represent growth. This star in Virgo's hand is named Spica, and Spica actually means ear of grain in Latin. And you can see the constellations kind of holding Spica. Now, a few of these constellations I just showed you might have sounded familiar to you. Virgo, Leo, Gemini, and Taurus. These constellations belong to a famous group of constellations. There are 12 constellations in this group, and you might have heard of them or seen them in the newspaper recently. They're called the constellations of the zodiac. Now, these constellations circle our celestial sphere, which is why you only see certain ones during certain times of year. Chances are you know these constellations best for their association with astrology. Astrology is the practice of using constellations to predict things about people, like your horoscope or your personality. Each constellation is called a zodiac sign, and they're traditionally associated with ranges of birthdays. Now let's go back to the visual aid I had earlier. Just check in comments, guys, to see if anybody put anything up. If I didn't miss anything. All right. Okay, so let's bring our armillary sphere back. Here it is. Yeah, let's make the Earth not invisible again. There we go. All right. So again, the stars here are laid out in a sphere around the Earth, and these are where the constellations are. Now, I told you that the 12 constellations of the zodiac circle the Earth, and they do here as well. And it's going to be a little hard to see them here, but they follow sort of a notched line. You can see that line kind of going around the sphere here. So we have Pisces there, and we can continue on around to find other ones like Capricorn and Sagittarius, and they all follow this plane here. And we have a name for that plane. It's called the plane of the ecliptic. Now, you might also be able to tell that that plane coincides with the sun and the sun's position. So if I move the sun, now I want to make very clear that although on my armillary sphere, the sun is rotating around the Earth, that is not how the universe is laid out. And this is just for visual purposes, so you can understand the relationship between the Earth and the sun. But the Earth does go around the sun. Hopefully we don't have to do an entire stream explaining that. You can take my word for it. But as you can see, the sun's relative position to the Earth appears along that line. So as the Earth orbits the sun, relative to the stars behind the sun, it will follow this line. And again, this is called the plane of the ecliptic. It also maps out the plane of our solar system. So all the planets orbit in a flat disk along pretty much the same plane. So as the Earth orbits the sun, maybe if I keep the sun in one place, if I try to keep the sun in one place, maybe that would help. So the sun is right there. Or let's do it from this angle. All right, so the sun is there. And so let's try to make the Earth orbit the sun. So if the sun is kind of staying in the same place and the Earth is going around it, you can see how the stars will appear to move behind it. So if you look from this angle, throughout the year, the stars behind the sun will be changing. Now, you obviously can't see these stars behind the sun, but they are very important to how the zodiac constellations work. So let's return to being invisible. Let me try to make my eyes not so glittery. We're still figuring out this new technology, folks. Thanks for your patience here. Whoa, that's crazy. We're doing this on the fly. We're kind of losing some light, so we may just have to deal with a little fuzziness behind me. That's okay. So the zodiac is actually, like I said, more closely tied to the sun's path. So actually, if I rewind time back to daytime, and we turn on some of the constellations behind the sun. Oop, I'll be able to do that. Let's just turn on all of the constellations. All right, and let's see, turn that on too. Okay, so this line in the center here is the ecliptic. And the sun will appear to move along this line throughout the year, and it'll pass in front of the 12 constellations of the zodiac. And if I rewind more, you can see how these constellations are lined up. So we have Pisces there. And then there is Aquarius. And then now you can kind of see below there. That's Capricorn. A little bit easier to visualize in the planetarium, so you'll have to bear with me, but hopefully you can understand that. So the constellations are all lined up where the sun appears. It's kind of like how when you drive down the road and the trees fly by your window, you know the trees aren't really moving, you're the one that's moving. This is the same case, where it looks like the sun is going in front of where the constellations would be, but the constellations and the sun aren't moving, it's the Earth that's moving. All of that to say that depending on the time of year, the sun will appear in front of a different constellation. That's why they say the sun is in the house of your constellation on your birthday, because on your birthday, the sun is in front of one of the 12 zodiac constellations, and that is meant to show you which constellation is your zodiac sign. So we've returned to our early evening. Actually, I take that back. What we want to do, now normally we spend our star tours right after sunset because that's when most people are going to be stargazing. If you stay up late, you can see a lot of other stars and constellations, of course, but to keep our content from just being too much to handle and too much to take in, our star tours we usually focus on one time right after sunset. But I do want to fast forward to tomorrow morning right before sunset. Some of you might be able to get up early, and it might be worth doing after I show you what is going on in our early morning sky right now. And we are most likely going to have to hide Memorial here. So we're actually going to switch to just a lovely field of flowers. All right, so if you don't have a giant World War I monument blocking your view to the south tomorrow morning, right before sunrise, looks like right around 5 o'clock. So before 5 or 5:30, you'll be able to see quite a view towards the south. You'll be able to see the moon tonight. The moon tonight is in a waning gibbous phase. Waning means that the moon is getting dimmer and that more shadowed, but gibbous means that it's more than half full still. But you won't be able to see it till early in the morning. But then lined up right behind it are 3 bright points of light that, if you look closely, you might notice are not twinkling. Well, these are planets. Now, this is a really, really special thing that we are seeing this spring and summer. These 3 planets are all lined up, and they do not often line up like this. These planets are Mars, Saturn, and Jupiter. Now Mars is a planet that moves relatively quickly, so you'll be able to see it kind of changing positions quite a bit throughout the year. But Jupiter and Saturn are much further away from the Sun than Mars and Earth, so they move a lot more slowly. As you can see, Jupiter and Saturn appear very close to each other right now. Now, this only happens once every about 30 years. So this is a really special event that we're seeing. And they are actually getting closer and closer together. And pretty soon they will do something that we call a conjunction. A conjunction of planets is when two planets appear as close to each other in the night sky as they will ever get. Obviously, they're not right next to each other in real life, but by their angles, so Saturn is further away from Jupiter, but they'll eventually look like they're right next to each other, and we call this a conjunction. And then Mars is kind of getting in the mix too. But like I said, Mars will be moving a bit more quickly. Let's go ahead. I've got a map showing this conjunction in greater detail here, where you can see how this is happening. So there will be a couple different times where Jupiter and Saturn will be pretty close, and they'll actually be doing this weird zigzag. This is called retrograde motion. You might have heard of that word in astrology as well, but all that means is that due to the movement of the Earth relative to the movement of the other planets, for just a brief period of time, the planets will appear to go sort of backwards in the night sky. That's what we call retrograde motion. So both Saturn and Jupiter will do this retrograde wobble around the same time. But on December 21st of this year, they will be in what we call the Great Conjunction. That is the closest that they will appear. They will appear 0.1 degrees away from each other, right next to one another in our evening sky. And that will be quite a sight. And that will be something you'll definitely want to get access to a telescope to see. And if the weather's nice, we will for sure be doing a viewing opportunity with telescopes at Union Station to see this Great Conjunction on December 21st. So stay tuned. Obviously, that's a little bit ways out. But you can see there are a lot of other periods of time where they'll be pretty close. There's a semi-conjunction here on May 18th that's coming up, so they'll appear 4 degrees apart from each other, 4.7 degrees apart. Now, they'll also be hitting their opposition right around this time, too. A planet opposition is when they appear closest to us in the night sky, so they are biggest and brightest that they ever appear during the year. So Saturn's opposition is on July 20th, and Jupiter's opposition is on July 13th. So right around summertime, Jupiter and Saturn are going to be really, really, really bright. And you'll be able to see them much earlier in the evening as well. So stay tuned for that. But for now, you can see that awesome view of the 3 planets all lined up. This is more of a temporary thing because, like I said, Mars is moving out of the way. Mars was on that chart. You can see the red dots here. That shows Mars. And Mars will have conjunctions as well. So on March 20th, actually, Jupiter and Mars were in conjunction, pretty close together. And Saturn and Mars were in conjunction on March 31st. So they're kind of moving out of the way now, but they are all nicely lined up, so it'll be quite a show. So set your alarm early. Try to wake up early and see this awesome show before the sun rises towards the south with the moon, Jupiter, Saturn, and Mars all lined up nicely. And that'll be quite a sight that we won't be able to see for a long, long time. Now, this is what I wanted to cover during our little star tour today. I do see we had a couple questions come in, so let me answer those real quick. Stephanie is asking, why do stars twinkle? That's a great question. Stars are really far away from Earth. The closest star to Earth is 4 light years away, and most of the stars you see in the sky are much further. And stars are so far away that by the time their light reaches the Earth, only a tiny amount of it is able to pass through and penetrate the Earth's atmosphere. Now, our atmosphere is filled with gases, lovely gases that we enjoy breathing, but gases that cause distortions. And as those tiny specks of light enter the atmosphere, the gases cause them to appear to wobble and twinkle, and that's why stars look like they're twinkling. Planets are much closer than distant stars, so more of their light reaches Earth. And if you looked at a planet through a telescope, it would appear as a disk of light. Stars, when you look at them through telescopes, still appear as tiny points of light. And then Jason is asking, are those spheres available in the gift shop? I'm not sure. I don't think that the Science City store has sold our Miller spheres. You can find these online, though. Let me see. So Robert's asking about our Miller spheres as well. So yeah, you can find these online. They're a bit pricey. and can be slightly delicate, but they're pretty cool. And they're great astronomy tools. This one glows in the dark even, and it has all the constellations on it, has the plane of the ecliptic, and a decent globe on the inside. But if you want to start out with something a little bit simpler, like I said, you can download a planisphere to print out, and you can buy nicer planispheres that are printed on heavier material. But I believe, a link to that has been posted in the chat of the Union Station stream on the Union Station page. So you can find that Instructable, where you can print out your own planisphere and make it home. And let me just triple check to make sure we're not missing any other questions. Okay. So one last question. Kelly just asked, how do stars die? And this will be where I end the tour, and I will answer that question, unfortunately, with a tease, because on Wednesday at 6 p.m., the theme for Wednesday's deep dive show will be all about the life and times of stars. We're going to learn about stellar evolution. We'll learn how stars are born. We'll learn how different stars live and differences between them. And then we will talk about how stars die. And they die in a couple different ways. One of those ways is a black hole. So be sure to tune in on Wednesday at 6 p.m. On the Union Station Facebook page, or the Science City Facebook page, or the Planetarium Facebook page. We'll be streaming on all three pages. If you haven't liked the Planetarium Facebook page, be sure to go over to there, to the Arvin Gottlieb Planetarium Facebook page, and give us a like and subscribe, so you can so you won't miss any more fun facts about space. We've been following along the Apollo 13 mission, which has its 50th anniversary right around now. So you can learn more about that there on the Planetarium Facebook page. But for now, this brings us to the conclusion of our What's Up Star Tour for this Monday. Thank you all so much for joining us and for asking any questions. If we missed any in the comments, we'll be sure to write those down, and we'll hopefully answer those on Friday, when we will be answering even more fan questions. And I hope to see you all on Wednesday. Once again, I wanted to thank all of our Union Station members for continuing to support us during these uncertain times. And I wanted to encourage anybody else who would like to support Union Station in any way to go over to unionstation.org, and you can find out how you can support us there as well. This has been Patrick Hess, your planetarium specialist, signing off. Thank you so much for joining us today. Happy stargazing, and have a great week, folks.